Hi, it's vintage Tekscope time. You may remember these. Somebody sent these two classic Tektronix 2465 scopes. One's the original 2465 and one's a 2465B, the coveted 2465B. Some say, many say, the best analog oscilloscope ever made. Argue down below in the comments. Now, my recent visit by Nobel laureate Barry Marshall, if you haven't seen that video, seriously, even if you don't think you'd be interested in hearing a Nobel Prize laureate's story, trust me, it's really good. Everyone who watched it thinks it's absolutely fantastic. I'll link it in at the end. Anyway, he's a vintage tech buff, as well as having a Nobel Prize. And he's actually got a 2465B, and he loves these things. So it reminded me of the 2465, the two of them that I've got here. Sorry to whoever sent this in, I forget your name. It was a couple of years back. I've had these sitting on my shelves in the background in my mailbag segments for quite some time, and they both are scrap units, but I thought I'd power them up and see what the status is, because I can't remember. I think one of them had a power supply hiccup, the other didn't. This one has no trace written on the inside of it, and it's scrap. And both of them don't have cases on them. But I thought it's worthy of actually having a look, see if we can fix this. I'd much prefer to get the newer one, the more modern B series one going, because it's 400 megahertz as opposed to 300 megahertz. I do like the classic blue screen on this. I don't know why this is the red, this like maroon kind of color. It looks, I don't know, I just don't like the look of it. Much prefer this one down here. So I'm not sure the history of that change or not, the graticule changing like that. Anyway, if you do know, please let me know. But absolutely classic scopes, and they're worth taking a look at. And yes, I did upload the video on the second channel, the Tektronix, the ancient, what is it, 465 or 475, and that's a sort of like in progress repair. But if I'm going to spend the hours on it, I'd probably rather spend some time trying to get the 2465B fixed. So let's power it up. Have a look. Now, if you have a look inside both of them, this is the newer B model, this is the older one. You can see no trace scrapped. Somebody's written that on there. And they basically have equivalent power supplies. They look absolutely equivalent. They have the same interface, all that sort of stuff. But of course, this one looks more modern because it is. And everything looks very similar between these units. But this one, the older one, does have an extra card on here. I believe that's entirely integrated in the processor board on this one. But apart from that, they are very similar. Now, as far as the main processor board goes, I don't even think I need to tell you which one is the more modern one. It's obvious with all the surface mount down the bottom. And look at all the beautiful through-hole resistors on the top, though. Look at that. That's just a thing of beauty. It's joy forever. But anyway, the new modern B one, it's all surface mount, none of that through-hole rubbish. And what's the processor? An SC6712. What's that? I'm not entirely sure. Anyway, yeah, the Dallas Semiconductor, that the non-volatile one. This is 32nd week, 1990. So we're talking, 30 years now. So, geez. Yeah, that battery will be no good. But anyway, that's the least of our concerns now. So we're looking at getting a trace up and running on this thing. And the older one is 94 vintage. You're gonna, well, they're the ROMs. 84. 84. Sorry, I was looking at that. I was looking at 94, 95 there, and I thought, geez, that's pretty recent. No, the other one's 84. Wow. Okay, 1984, and you can see the numbering on the chips as well, 1984. So, yeah, that's quite a significant difference there. So an extra 6 years and an updated model, that makes all the difference. And as for all the analog stuff on the bottom with all the custom ASICs, look at all these custom heatsinks. Every one of these is a custom jobby. They're near identical. There's a few differences, like, immediately spotted, like this down here. Like, it's got a little ground link and one resistor. This one's got a ground link and a couple of diodes and a bunch more resistors. But apart from that, the layout, this one's got an extra trimmer in there, does it? There's you know, there's a few differences, but largely the architecture is very similar. So maybe they could, so obviously I could possibly use one as a parts unit perhaps. So definitely, if you're going to repair these, obviously it'd be ideal to have like the same model, but should be able to at least salvage some parts if we ultimately need to on the from the A unit. So all the tech buffs out there. And by the way, no, I am not going to consult. I should. If you're going to repair these, I highly recommend you consult like the Tektronix Repair Yahoo group and stuff like that. They will be screaming at me during these videos that, oh, that's obviously that capacitor there. It's, oh, that diode, that transistor fails all the time. Everyone knows that. Well, yeah, okay, I'm just going to wing it. Sorry. You can see small little changes, like these have discrete wiring just going to headers from the controls, the knobbies on the front, whereas this one over here, the newer model, looks like it has flat flex on there. So just some, sort of tidy up improvements in terms of manufacturability. And from the side, near identical as well. These board has changed, but the functionality hasn't. The wiring, I'm sure the wiring's even all the same. So yeah, they've just changed the pots over, but it looks similar. All right, here we go. I'm going to power up the new 2465B. A lot of people will recommend, don't power it up, just go in and automatically change all the caps and blah, blah, blah. Yeah, okay. Okay, here we go. All of the lights come on. That's good. Will they go out? I do remember when I used to use one of these babies, they used to come on as a power on test, but they ain't going off. No, it shouldn't take that long. You can see it if I turn the lights off. There we go. That's nicer. Annoying thing about this power supply, they don't really have any test points marked as such. No voltages marked on there. Terrible, Muriel. And we have some crop circles. I'm not saying it's aliens. And I can't see any marked voltage test points on this board. Maybe there is one, I've missed it, but can't see diddly squat. I'm sure the service manual has it all covered, but geez, put it on the silk screen, please. All right, do we have 5 volts on our board? Let's go across a random chippy. Yep, 4.97, 5 volt rails, all right. Presumably, that's why all our LEDs are lighting up, because they'd be under logic control. Just for kicks, let's plug in the older 1984, was it? 85, yeah, 84, 83 model. Let's go. Oh, it's hiccup in. I hear something hiccup in. Tick, 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 tick. This scope will self-destruct in 10 seconds. Now, upon a close visual inspection of the board, check this out. We've got some corrosion on these parts around here. That's a resistor of these 2 caps. I reckon these electrodes, they're looking pretty sick. So I reckon they've spewed their guts everywhere. And there's the same cap up on the other end of the board. That looks a bit crusty, rusty too. So yeah, I suspect all those caps are gone. Well, you're not going to believe it. All of the test points, voltage test points, are on this 14-pin dip socket here. Who would have known? J119. Yes, I had to read the service manual to find out, although if you follow the money, those pins down in there, they actually are what go through to the power supply board on top, but they're not really labeled anything. You can physically follow them, so yeah, really, you had to RTFM to know what these supplies are. And sure enough, in our service manual, ridiculously comprehensive. I'll link it in down below. Crazy. Anyway, let's measure all our test points. So these are all the, not in order, which is kind of annoying, but these are all our different rails on here. So let's measure those. We already know the digital plus 5 volt digital seems okay. I'm not measuring ripple yet. I'm just making sure they're in the ballpark. Okay, pin 1, minus 15. That is minus 15. Surprise, surprise. Pin 2, digital plus 5. Already measured that. Yep, it's good. 4 is plus 10 volts. Oh, bang on. Look at that. Well, one least significant digit out, but come on. Minus 5 volts. Winner. 6 plus 15. Wow, that is bang on. 8 plus 87 volts. Now we're getting high. Bang on. This is ridiculous. Surely one of them's got to be fail. 9, 42.4. 42.3. Oh, it's a little bit low. It does tell you the tolerance on here, by the way. It is within tolerance. 11 is minus 8. Lucky last. Analog plus 5 on 12. Wow. Winner, winner, chicken dinner. All of our power supplies on this are fine and dandy. Doesn't mean you wouldn't go in and fix the caps or anything like that. But all of our LEDs on the front are just on. So it's not going through the sequence. I might read the manual and see if it says anything about LEDs stuck on. But yeah, anyway, we do know we have some dodgy caps on there. And that non-volatile SRAM, that's got to be Gonski. By the way, you might be able to see down in this power supply, there's a reefer madness capacitor down in there. Oh, in fact, there's 2 of them. You see another sneaky one down in there. Yeah, I'm going to want to replace those, but right at this moment, no. Yeah, I need to solve the digital problem. Now, as it turns out, there's actually a whole set of comprehensive tests when this thing powers on. Let me turn the lights off. There we go. And they are indicated by not only on the CRT, like as in text on the CRT, but obviously our CRT isn't working here. In fact, beam find? Nah, zippity doodah. Nothing's readout intensity. No. So, no good. Even the scale illumination's not working. So, yeah, no, that's one sick puppy. But anyway, it does kernel tests first, like basic kernel tests, and errors are indicated by various LEDs lighting up on the front panel. But I don't see, and then it goes on to more routine, like more thorough tests of all sorts of stuff. But I can't see anything where all of these are lit up. It doesn't say anything about that in the manual. So are they actually on, or are they just bleed through from the other? I can't really tell. It does take time, so obviously the processor's doing something, because the processor has to drive the... Oh, saw something on the screen there. Did we? Yeah, look, got something. Wow, okay. That's, whoa, yeah, all right. It doesn't say anything, not that I could find, about all the LEDs lit up, so meh. Is that the RAM? So I'm just going to measure the ripple on the 5-volt digital, because that's all we care about at the moment. So I'll whack it on AC pin 2. The spec is 150 millivolts peak-to-peak ripple, and we're getting 350 millivolts. So yeah, our 5-volt rail, it's got a lot of ripply on it. That would explain a bit. Okay, I just want to have a look at that ripple with the scope. We're at 200 millivolts per division, so yeah, there's your problem. We're only supposed to have 150 millivolts peak to peak, so our ripple is absolutely enormous. Whether or not that's causing an issue, I don't know, but that's really not even in the ballpark compared to the total spec there. So yeah, you'd probably want to fix that first before troubleshooting further. I've got to say, they're getting this power supply out of here is pretty horrible. It does actually slide out if you undo some screws at the bottom there, but then some of the wiring, especially to the voltage selection switch on the back, they've got little spade terminals that have to be lifted off the board in this direction, but they're hidden behind here, and to get these, it's a mess. Don't like it. Ta-da! I've got a big strapping earth lead there. It's a bit how you doing? Oh, and there they are. They don't looking good, Nick. Look at that. This just looks all cracked or whatnot. Yeah, I'd be just sucking those out as a matter of course. Anyway, what we're really interested in is the 5-volt rail here, because we want to solve our digital problem first. So that's going to be our 5-volt main supply under there. There's our big DC input filter caps after the bridge rectifier, because this is a switching converter, obviously. And there's another sneaky bugger down in there, and yep, that's genuine reefer madness. And there's a thermoelectric mechanical switch in there for measuring the temperature of the power trannies on that heatsink. I love the casings on them. Look at that. 3 power trannies there. Anyway, that's just in short, that'll just auto cut off the supply if that heatsink overheats. Now, of course, the really annoying thing about this is that the connectors are labelled on the silk screen. You know, you got your J's, fine, but as I said, there's no voltage test points, there's no like voltage marked test points or anything like that, but all of your capacitors, these aren't labelled, like, you know, C100 or whatever. You've got to actually go and get the service manual and schematic and get your board overlay, which is like, okay, well, fine. Okay, the manual's ridiculously comprehensive, like hats off. They just don't make them like they used to. Absolutely fantastic. But yeah, you've got to go in and get your overlay. So it's really annoying. Anyway, what we're interested in here is our 5-volt regulator. Here it is. And our output cap, C1280, that's our 5-volt rail. Okay, I like this, that it's labelled C1280 like this to match Q1280 up here. They label them in sections. That's a trap for niceties. I think I covered that in my good schematic design practice video, didn't I? If I didn't, well, it should have been in there. Yeah, like match them group label like this, because, you know, if this was Q1280 and this was C101 or something like that, it's just not as nice. Have them match up. Anyway, so we will check our output cap, but also because the ripple, this isn't going to be a magic ripple rejection here, we're going to look at this one, which is the plus 5-volt unreg here. The printout didn't show it, so we jump over to here. And sorry for the crudity of this, but if you have a look at the 5-volt unreg down in here, I think it's that one, C115 there. So we've got a 250 mic cap down in there. So that's the input side to the unregulated one. So we want to check those 2 caps. They're probably dead as a dodo. So C115 there, it's that puppy, and which is different to these ones. These are brown ones. These are probably lower ESR ones. So this would be a 5-volt cap. That's our unreg cap, and the other one. And then C1280 is there. So we've got a flippity doodah, and C1280. Which one is it? That puppy there. But because they're all identical like that, you know, if you got one fail, you would also suspect and measure the others. And a lot of people will go, oh, well, bugger it, I got the board out, I'm replacing every single electrolytic in this thing. It's already like, what is it, 35 years old or something. And yeah, I don't blame you. So I don't know if I want to do that. I just want to get the 5-volt rail. I just want it to sort of see if that's causing the problem of like not booting up, so to speak. So one side of the board flips out here, and wow, look at that burn mark from that regulator. Isn't that terrible, Muriel? Yeah, well, it obviously gets hot, but there's no indication that that one's failed at all, because all our rails measure just fine, so no worries. Anyway, want to suck out that. I'm just going to measure it first, see if we can measure anything in circuit, anything funny business, and we'll get that out. And they've got a shield between here as well, which is actually connected. But yeah, more burn marks down on there. Oh, somebody's had a, hang on, is that a Harry Hacker? Somebody's, or are they just hand done? Look, there's a bit of a Harry Hacker down there. With they look bodged on, and all the flux residue, it doesn't look like any of the others. Were they done by hand at production time? I don't know. Maybe. Does anyone know? Oh no, check it out. Look, the row of these caps here we think that one's failed on the file suspect. Look at that. These ones are fine. These have got the original wave soldering on them. That one's a Harry Hacker. So yeah, someone's had a go at this. Okay, we'll just do a crude in-circuit ESR here at 100 kilohertz. So let's, sorry, it's this one over here. This is our 5 volt one. This is our suspect one. 0.3, 0.27 ohms. That sounds pretty good. Let's measure the other ones, which are all identical type and value. 0.29. Yep, that's good. That's good. There you go. So they're all the same. So, oh, hang on. Just got to pierce through the flux there. That's where you need sharp probes. There you go. So all those ones look, they're all the same. So, you know, you wouldn't really suspect that. You might suck it out and give it a more thorough test, but I would say that one's okay. So that's the output capacitor, the output of the regulator. So the other one is this one here, 2.9, almost 3 ohms. So I suspect that one might be cactus. That would explain it, the pre-regulator one. So, yep, let's suck that out. Well, something is very wrong here. I sucked that out, and it's only a 10 microfarad, 160 volt cap. Nippon Chemicon. But what the? What? It's supposed to be a 250 mic, like, and you'd only expect like 10 volts or something. This is ridiculous. I definitely have the correct capacitor. Look, there's 2 there. There's a third one up there. There's 2 here. A third one up there. C111 5. And like, what the? This is the same board. I'm sure this is the same board. What the heck's going on? Wow, you're not going to believe this. There's actually an error in the manual. Believe it or not. Whether or not they fix this in the errata in later versions, I don't know. But C11115 and C1132, it looks like they're swapped on the overlay here. Because I was tracing out the board here. I was tracing it out, and it's supposed to go to this, 5 volts was supposed to go to this inductor over here, and it didn't make sense. It was going to this cap here, and it was crazy. So yeah, they've actually swapped these 2 caps. So I googled this, and sure enough, yep, up comes the EEVblog forum. Howard Long, who's a long-time contributor on there, he discovered the same fault as well. And yeah, the bloody service manual is swapped. So there's nothing wrong with that cap, of course. Measuring that sort of ESR for a 10 microfarad 160 volt cap is just fine. So that's the 5 volt jobby there. So that's the culprit. I need to solder that back in and suck that one out. Unbelievable. And that dodgy little sucker, which somebody's had a Harry Hacker at, 25 ohms at 100k in circuit. So yeah, let's suck that little turd out. And is that an original or not? I suspect not. And she's about 22 ohms out of circuit. That's too high. And 1.5 microfarads, 1500 nanofarads for all you nanofarad fanboys. Yep. That'd explain our poor pre-regulation on that thing. And of course, all that ripple is just, oh, he's dropped on the floor. All that ripple is passing through the regulator onto the output. And back at 100 hertz, 142 mic. Yep, that's no good for a 220 mic. That's way under. It's gonski. Now I've replaced it with just a generic one hung low brand 330 mic 25 volt cap. And well, yeah, I know I shouldn't do that, but that's all I've got at the moment. So the lab is an absolute mess. I just want to get something back in there that's going to get that 5 volt rail operating again. And just for now, I want to put it back in. I won't bother replacing any other caps in here. Just looking at the 5 volt rail. One thing at a time. And of course, you wouldn't do this if you're experienced with these sort of things. You'd go, oh, like you'd have kits that just replace all the caps and, you know, like stuff like that in this old bit of gear. But for the purposes of this video, please do not comment about this down below. Just for the purposes of this video, I want to see if just changing that one cap makes a difference. Okay, let's see what happens. I haven't changed any of those leaking electrodes on the main digital board. just wanted to solve that power supply problem. So here we go. Now lights are different. Lights come on. No? Didn't come on before. They're all on again. Bummer. Okay, well that could still be the electrodes on there. So let's have a look at the ripple. All right, we're 200 millivolts peak to peak again. Let's power on. Whoa, no. We're still cactus. That's no good. So I sucked out that secondary cap, or like the output cap, 0.22 ohms. That sounds pretty good. That's what we had before. So let's go to, let's change our frequency back. 100 microfarads, and that's, oops, off camera, 100 microfarads. That's what we expect. So that cap's actually in good nick. It's a Nichicon. All right, so I'm going back to these other caps here, which have all been sucked out. So let's have a squirt. Like I think I might just go in there and replace the blinking lights. Something could be bleeding over to the 5-volt rail, but I can't really see how. But anyway, okay, I've actually replaced all the caps there, or at least all the major ones. So let's switch on, and it's hiccuping. Look, check that out. There we go. That's progress. Hiccuping power supply. Hiccup, hiccup, hiccup. Okay, I'm going to capture the 5-volt rail again. There it is. Whoa, that's 2 volts per division. So as you can see, it's starting up 4.5 volts, and then it basically just shuts back down and repeats every second or two. So that's very interesting. Going from a working in quote marks. Oh, hang on. Look, it's going through its self-test. Hang on, it's not hiccuping. We have a trace. Woohoo! What the? I just went away for 5 minutes to have a look at the manual, came back, and it went through its power on self-test. Winner. So I'm not sure what that hiccuping was. There might be something else a little bit dodgy in there that was tripping the some sort of overcurrent protection. But wow, we're in like Flynn. Look at that. We've got trace. We've got trace. We have no display. Hang on. Readout. Yeah, we have some readout too. Oh, winner. It's all fuzzy though. Look at that. I don't like that. Is that some jitter on the readout? But hey, it went through the power on self-test. Let's try that. Whoa. 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 Woo. Hang on. Whoa, that's bad. That's bad. Hang on. Woo. A thing of beauty is a joy forever. Look at that. That's a Bobby Dazzler. We released the magic smoke. Yes, it's a brand new cap I put in. And yep, Pebcac. I put it in backwards. Oh, look at that. Isn't that just gorgeous? Insert meme here. Wow, that's just fantastic. That just spewed his guts right out there. Oh, Wilson! Yep, dumbass Dave put it in backwards. There's a positive and there's the negative. The reason I didn't see it is because I was looking at the board from this direction here, and I thought that positive was that one. I just was not paying attention at all. So there you go. That explains the hiccuping when we didn't have hiccuping before, of course. When you had a nice stable power supply, albeit we had a large ripple on the 5-volt rail, but all the measurements were spot on. There was no hiccuping at all before. And then all of a sudden we changed the caps and it's hiccuping. That doesn't make sense. Power supplies only hiccup like this when they have overcurrent situations. So yeah, it's obvious. This thing was in backwards. It was drawing a large amount of current and it was causing the shorting out that rail effectively, or loading it more than its protection current, and the power supply was hiccuping. Hiccup, hiccup, hiccup. That's what good power supplies will do when they have overcurrent protection. They won't just like shut off. They won't just blow a fuse. They'll try again and again, shut it down, try again, etc. And yeah, the magic smoke escaped. Brilliant. Yeah, lucky I've got another one. Anyway, yes, these are One Hung Low brand low ESR caps I've put in here. I don't recommend you use these for long term, but as you can see, it does. The scope now powers up and we got out of trouble. So, except I put it in backwards. Oh, anyway, I'm going to go in there. I'm going to replace some of the X caps as well while I'm at it. There we go. Got 2 new X-Class caps on there. Nice. So, and there you have it. Reefer madness. So, yep. Yeah, definitely. If you ever find these in gear, I've done a video on this. Reefer madness. Just simply replace them. Don't even power it up with these. I was a bit, it's a bit gun-ho. By the way, for those who are wondering about the scorch burn mark around there, there's nothing wrong with that transistor, I believe. Seems fine. It's just that it's gotten... some things in the 2465B get notoriously hot. I'm not sure if this is one of them, but obviously over time, it's just browned the fiberglass browned. Is that a word? Charred? The fiberglass or whatever. So the thing wouldn't work if that was Gonski. So yeah, obviously it's okay. So I'm going to leave that for now. Unless you know specifically that, something going wrong there. Let me know. You can see that we've got a similar thing happening. A bit of char in here. Yes, I'm going to clean up those joints, don't worry about that. Yeah, from these diodes, these power diodes, obviously getting a bit warmsky and just, over time, just degrading the fiberglass. That's all. Nothing to worry about if your diodes are fine. Okay, after that pebcac, I've replaced all the unreg main rail caps, and the reason the unreg ones are going to fail more than the regulation or the output side caps is that the input side caps, the unregulated ones, are susceptible to more ripple. So therefore they have a harder working life. The ESR is going to cause them to heat up in more internally, and they're going to have a shorter life than the output caps. That's how it works in theory anyway. So I've replaced those. I've replaced the X and Y class caps in this thing. So let's power it on again. Come on. Going through, it's going through, it's going through, it's going through. And bingo, we have that trace again, but we still have the fuzzy digits. That could be caused by, once again, there could be like an output rail cap or something on that, but yeah, that's a nice bright trace, isn't it? Look at that. So, that's pretty sweet. Nice. Actually, nope, that was just our focus there. That was just our readout focus. I was a bit taken aback because I forgot that it had separate controls for that. And so there you go. Our readout is beautiful. Our intensity, fantastic. And it looks like we've got some cursors here. Sorry about turning the lights off here, but it does actually look a lot better. Like you can, because these little LEDs are a bit wimpy. They always have been on these model tech scopes. I've never been a big fan of them. Horizontal position control works. Channel 1, channel 2, fantastic. I'm really liking it. And remember, I haven't replaced those caps, which look, I haven't measured them, but they look to have leaked and spewed their guts out and maybe corroded some of the nearby components on the board, on the logic board. But hey, it's working. It's working okay at the moment. Beautiful. Now, I don't recall if this is normal. I don't think so. Look, press AB trig and like a whole bunch of the LEDs sort of light up. That could be some of that, those decoupling caps on the logic board might be doing something funny, but it's obviously still operational because it's got it to do to put the text on the screen like that. It basically has to be fully operational from a basic point of view. So, yeah, can anyone let me know if that's normal? Doing like, oh, look at it. Yeah, no, it can't be. No, there's got to be something else. Something, yeah, look, you press actually any button. Looks like any button. No, set that. Oh, yeah, maybe. I can just see them flash. Oh, listen to those relays. Oh, Bobby Dazzler. And this has got 50 ohm input impedance too. Nice. Oh, I forgot. We can like turn on, where's our other stuff? We can turn on the readout intensity, the scale factors. Beautiful. Look at that. Now I got it all. Ah. There we go. Whoa. It's a little bit fuzzy, but geez, I'm not going to complain about that. That's for sure. Yeah, that's what the readout here, the readout dial, you can actually get it to go one side and it just shows the cursors. The other side shows the readout and the cursors. So that'll show you your volts per division. Oh, wow. Just going to power that up. Again, it's running through its self-test. So the non-volatile RAM, I mean, I thought that was supposed to like give an error or something if that didn't check some. So maybe there is a little smidgen of battery life still left in that puppy. And anyway, let's feed in a signal. Well, channel 1 seems basically functional. I'm feeding in a 1 kilohertz, 500 millivolt peak to peak, 484 millivolts on the cursors there. You know, you're not going to complain about that. So that's all right. No worries. And we've got 20 megahertz there, 50 millivolt signal, and yep, no worries. And the same on channel 2 as well. 20 megahertz signal, 50 millivolts. That's working just hunky-dory. So very happy with that. That's a 1 volt, 20 megahertz. Yep, beautiful. So there you have it. I'm going to call that quits right now for this repair video. It's gone on long enough. This is only part 1, of course. I don't consider this fully repaired or fully refurbished or anything. I would probably go through and replace. If you're properly refurbishing this and you wanted to use it over a long period of time, be confident with it, you'd replace every single electrolytic capacitor in there. I still have no idea about the digital caps on here or what function they actually performed. If they're faulty, haven't even measured them. I do know that they look like they spewed their guts. And by Googling, that does seem to be a known issue with the 2465s. Those electrolytic caps on the logic board do actually fail and they corrode away everything. But as you can see, we've got a fully functional processor. It doesn't look like it's lost any of its calibration stuff, so it looks like that Dallas non-volatile RAM is still just hanging in there by the skin of its teeth. Of course, you can't measure the internal battery voltage in there because the battery is actually internal to the SRAM chip. It's potted in that big black block on there. But yeah, you would replace that as a matter of course, like a long-term thing. You'd fully recalibrate this, and that'd be a whole video in its own right, fully testing every function and recalibrating this. But there you go. We kind of got a bit lucky on this one just by replacing a few unregulated side electrolytic caps on this, as well as there's some X and Y class reefer caps, which in this case hadn't failed, but they could spectacularly explode at a moment's notice. And it has come good. There you go. So so much for scrap and no trace on this thing. It was simple power supply, but it looks like somebody's had a shot at this because some of those capacitors looked like they had been hand soldered and replaced. So yeah, I'm not sure what's going on there, but look, we're on our way. This is absolutely terrific. So yeah, I expected more problems with something like this. And of course, I did take the easy way out by simply replacing all of the caps on the unregulated side inputs without really, like measuring the ripple on all the other rails. I just replaced them as a matter of course, and it just came good. So we got a bit lucky that there weren't any other faults, no faults on the high voltage side of things. I really expected a lot more fight with this thing in terms of getting it up and running. I thought maybe for this part 1 video, we'd at least get the processor sort of not, at least trying to go through a sequence, boot it up again and trying to get like a power on error or something like that because the non-volatile RAM's gone or those capacitors have gone or something like that. But geez, look at this. This is actually functional. It looks like it's basically functional scope. Right now, we've got our cursors, we've got our delta time. I haven't played around with the time yet, but there you go. Let's have a look at that. There you go, 50 odd nanoseconds. That sounds about right. Pretty happy with that. That's just fantastic. Times 10 magnification. It all seems to work hunky-dory. So, yeah, pretty darn happy. The ground on the channel 2 here seems to have a little bit of a little negative wiggle there. I'm not sure what's going on there, but the tracer's reasonably sharp, more than good enough, and all the readouts work. Can't believe it. There you go. So I was hoping for something a bit more exciting than cats, but we did get one blow up, so that was pretty exciting, I guess. Anyway, yeah, let me know what you wanted me to do with this thing for a potential part 2 video. But for now, that's a part 1 of the repair, I guess. So if you like the video, please give it a big thumbs up. And as always, I'm sure there's plenty of tech experts on the EEVblog forum, and they'll tell me all about this, no doubt about it, either on the forum or in the comments down below. So that's pretty impressive for a 30-plus-year-old scope. And it's been sitting just on my mailbag shelf, and all it needed was, you know, a brand new set of caps by the looks of it. Pretty remarkable. Yeah, anyway, argue down below about whether or not this is the best analog scope ever made. Oh, some people say, oh, it's the 2467 instead of the 65. Yeah, go on. Go for it. Catch you next time.